Hello and welcome to another assembly language coding video on the Commodore 64. And I say this every time, I'm sorry it's been a while since the last one. Busy and COVID and all sorts of things going on and work throughout all of it. So let's remind ourselves what we did last time. So we were looking at custom characters. So we did some code here that copied the characters apart from the character 0 from the Vic bank to a new location, which was at hex 3000 in the memory. Then we set everything to black, set the text color to white, and then we printed character 0 across the first line of the screen, and this is here at 3000 is where we define that character, which was a smiley face. So let's just have a look at that, and when we run, there we go, there's our smiley face. So in today's video we're going to do something very similar, but we're going to do a multicolor character. That's where you can have 3 colors on your character. So just explain a couple of things first. Let's get a new file going. Video 8. So the character normal high res character is 8x8. Okay. So it looks like this. These are the things we can plot. However, a multicolor character is like a multicolor sprite. We only have 4 pixels across. Well, I say pixels, it's not. We have 4 blocks across instead of 8, and each block is 2 pixels, so we do lose a bit of definition there. So it's going to be like this. And I'll when we draw it out. Okay, so what I'll do, I will make it quite a simple shape, just maybe some different coloured stripes going along it or something like that. So how do we do this? Let's start putting some code in. Okay, so we want to import our source files. We might as well just copy this from here. So a lot of it's going to be the same, but I'll go through anyway as a reminder. So first thing we want to do is expose the characters in the Vic kernel temporarily, copy the characters from there, or most of them. We don't actually copy all of them, we copy most of them. Copy them to location 3000, but we don't copy the first one, we copy the second one onwards, because otherwise we'll overwrite our custom one, just purely because of the way I've done it. When you're coding normally, you'd put your custom characters into a separate location of memory and then copy them over once you've copied your other ones over, so you don't overwrite them. Okay, so let's do this. So we stop interrupts for a minute. Okay, we load the accumulator from memory location number 1. We AND it with, oh, I don't know what's going on here. We AND it with 251. Okay, if you want an explanation of why we're doing all this, just check the previous video out, and I do go through it in detail. So we AND it with 251 and store it back in 1. So now that's done that. That has exposed the character from the Vic chip bank, all the characters, definitions. So let's do a little loop here. That's handy, it remembered that from last time. So we'll, first of all, before we do that, let's load the X register from the starting number. And because the first character will use 8 bytes, we want to start at 8. So we want to go from 8 to 256 instead of 0 to 25, well, 8 to 255 instead of 0 to 255, so we don't overwrite that first one. So we load the character, load the first character from Vic base, and we put the X offset, so it'll be start from 8, then the next loop will be 9, or right up to 255. Then we'll store that in memory location 3000 and with our offset. Then we'll increase X by 1, and if it hasn't reset past 255, we go back to the character init loop. Okay, we'll scroll down a bit here. Okay, so now we need to change what we did here with the memory location 1. So we don't need the Vic bank exposed anymore in this way. So we will load the contents of 1 into the accumulator. And we'll basically do a reverse of that and 251, which will be ORing it with number 4. And storing it back in location 1. Right, so that should copy all our characters over. And so the next thing we need to do is look at how we can enable multicolor mode. Right, so here we have the Commodore 64 memory map, which we've seen a lot of in this series. What I'll be particularly looking at is this register here, which is the VIC control register, screen control register. If you look, bit 4 here is multicolor mode on. So that's 0, 1, 2, 3, 4. So it's this bit here that we need to change. So we can turn that on quite easily just by doing a OR command with the number 16, which will just flip that bit on. That's exactly what we want to do. So let's get back to the code. In our constants, we don't have that address defined yet, so let's do that now. So in our constants file, we'll just do a const of vic cont reg, or something like that. So vic, oops, reg, and that's D016. So we'll save that. Let's just line that up nicely, like that. Okay, and we'll copy this into the clipboard so we can use it here. So now we've copied our characters, and we've still got interrupts disabled. We can change our screen to multicolor mode. So the way we will do that is we will load from the accumulator Vic control reg. Let's just put a little comment in here. Remember how to do it. Enable multicolor mode. So load the value of the Vic control reg in. We'll OR it with 16, so it turns that bit on, whether it's off or on. It just makes sure that's on without touching any of the other bits. And we'll store that back into Vic control reg. Okay, and then what we'll do, now we've finished our initialization, we will enable the interrupts again. So there, now we've done our little bit of initialization. We can run it and see what happens. I don't think it'll do a particularly exciting thing. No, there we go. It's done nothing at all. So let's explain about how 16 multicolor characters work. So you have your background color, which in this case my background is black, but you can change that you can change. We can change the background colour in pokes. We've got our foreground colour, which you see I've just changed to white, and then we have two other colours which are the same for all of the characters. So when you're designing your game maps or your backdrops or whatever, then you need to remember that there's going to be two colours that are going to be constant in all of the character colours. And if you look at a lot of game maps carefully, you'll see that, especially if they use all three colours. So another thing to remember is you only get a multicolour character if your foreground colour, which see where it's gone from light blue to white, is in the second half of the colours. We've got 16 colours. We've got 0 to 7 and 8 to 15. They'll only work from 8 to 15. And the reason Commodore have done that is so you can mix normal characters and multicolour characters on the screen at the same time without having to change modes halfway down a raster line, etc, etc. So you can have your score written in normal lettering, and then you can have your trees and water and whatever else as multicolour characters on the same part of the screen. So that, although that does limit you slightly to the colours, don't forget it's only the foreground colour that needs to be in the second half of the colours, because you've got the background colour and you've got the two constant colours as well, which can be any of them. So bearing that in mind, let's get on and do a character. So let's set our screen up. So we'll load colour black into the accumulator. We'll store it in the border colour, which is already set up in my constants with the American spelling of colour. And we'll store black as well into this screen colour. We will load a light red, because that's one of the second group of colours. And we'll store that in text colour. So now we need to set some more constants up for our two text colours that are going to be constant here. So let's come out of the zoom. We'll go back into here. So if we look here, we've got border colour, screen colour. So let's pop it in here. So we've got text colour. I'm going to spell it English as well, because I'm like that. Okay, so the address for that, which is in the Commodore memory map, obviously, is D022. And you can probably guess what address text colour 2 is going to be. D023. Oh, and if you type it properly, it's even better. So we've now got these in here. Let's flick back to our code. So let's try and mix the colours out. It's probably going to look hideous, but let's load yellow in. And we'll store that in text colour 1. Okay, and for text colour 2, let's have blue. So now we've set our colours up, let's clear the screen. And if you remember from the previous video, we had to point the graphics pointer address, or the memory address, at 3000 to tell the VIC-20 where our new characters are and to use them. So again, check the previous video for that. Let's put a comment in. Point character bank at 3000. Okay, so what we will do, we load graphics pointer and we AND it with 240. Clear the carry. Add 12. Oh, I can't type today. I've been doing it all day, that's why. And store it back into the graphics pointer. So now the VIC chip is pointing nicely at our new custom characters, of which we've got nothing in character 0 and the standard ones in for the rest of the from 3008 upwards. So, and the last thing to do is we did draw a line of character 0, which we did before. So we will load into the accumulator, into the X register story, 40. Number 40, because there's 40 columns, 40 characters on the line. So we set a little loop up, so load character 0, decrease the X register, because it goes 0 to 39, store that in the screen mem with our offset, so we did, what telly sense, and it does it again. Do a space and delete. Branch of it hasn't gone to 0, back to character loop, and then return back to basic. So let's save that. We haven't designed our character yet, we're going to do that in a minute, so let's just see if it does anything. There we go. So if you notice, the ready looks absolutely terrible because it is in multicolor mode, because I've turned multicolor mode on, and the actual foreground color is light red, which is because in the second half of the colors it will display it in multicolor mode, so I can type things in there and it looks like that. But if I change this to white, I think I'm not doing this very well. My key mapping, I don't know if it's Alt, no, I don't know where the control key is supposed to be. It's not changing when I do that. Well, yeah, it would put that in normal mode. Well, let's try. Let's see what we can do. We can change from L red to white. Does that do it? Yes. So because we're using a bank in the first set of colours, from 0 to 7, it would display it in normal mode. See? I wish I knew how to change it on the keyboard. Oh, there we go. I've done it. So the control must be the Commodore key, so I don't know what the control key maps to. Ah, it's tab. Oh, obviously. Okay, so white, normal, another colour, multicolour. And then that's how it works. So the last thing we need to do to get this, you know, looking properly is to actually design a multicolour character. Which we'll do down here. So let's put a little comment here. So, as I said, it's only 4 characters along. So we've got 1, 2, 3, 4. And the way we decide what colour these are is as follows. You've got to remember you've got 4 colours to choose from. You've got the background colour, which is like invisible. So you'd obviously include that when you design any characters with normally a 0 in your byte. So you've got the 2 text colour characters, and then you've got your foreground colour. So the way you design your character is as follows. As you've only got 4 spaces, you use a bit pair for these, and the bit pairs work this way. So 0, 0 is the background, 0, 1 is text colour 1, 1, 0 is text colour 2, and 1, 1 equals foreground, which, let's change this back to light red, L red. So let's just do something very, very simple, okay? So what we want to do is we want to make it a square of just the foreground at the moment, which you could do normally, but I'm just going to show you how that would be. So it will be four spaces per line. So if it's going to be 1, 1, 1, 1, 1, 1, 1, 1. Which would equal, each line would equal 255. Okay, so if we did that all the way down, let's see if I can comment the whole of this so we can still use it. We would be looking at a byte value of 255, 255, 255, 255. So we need 8 of these. 255, 255. 1, 2, 3, 4, 5, 6, 2, 5, 7, 8. So let's run that. We should get a red square going all the way along. And we don't. Ha, the reason we don't is because let's comment out the right things. Otherwise, we're putting these bytes in at the next bit of memory after this. We won't putting it in at 3000. Aren't I stupid? There we go. So here's our red square going all the way along. So let's change it so it's half and half. So it's red at the top, and we'll have text colour 1 at the bottom. So we've got 4 lines of 255, and the next line will be 0, 1. So what would that equal? If you don't know binary very well, just open your calculator app, put it into programmer mode, and put 0, 1, oh, binary, sorry. 0, 1, 0, 1, 1, 2, 3, 4, 5, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Doesn't look right. Right. 2, 3, 4. 4. Idiot. 85. I keep forgetting there's, you know, there's 8 including, it's not 8 pairs, it's 4 pairs of 8. So yeah, it's decimal of 85. So let's do this last 4 of these as 85. Save that. There we go. So look, we've got a lovely character across there, which is half red, half yellow. We've also got another colour. So let us go to here, and so the next one we want is 10, 10, 10, 10. Now what's that, you ask? Well, we go 10, 10, 10, which is 170, or AA in hex. So let's put that in for these two here. 170 and 170. So now we should have all 3 colours in our... And there we go. Look, we've got all 3 colours. And I can flick back to white, and it's normal. I don't know if I can do the ampersand. I don't think I can. Which is character 0. So I don't know why the A is looking so bad there, but there we go. I seem to have corrupted the A somehow. 0, 1, 2. Yeah, I don't put any more in. It's interesting how I've managed to corrupt the A. I'm sure some of you eagle-eyed people will be able to tell me in the comments, because I'm starting at 8 when I'm copying them all. Yeah, that was fine, wasn't it? Okay, well, that's another story. Okay, so that pretty much brings us to the end of this video. I'll push this up to GitHub. I'll leave these notes in here. You probably don't need that. That's just my calculations. Well, actually, I'll leave them in there. So we've seen again how to copy the characters into a custom location, the built-in ones. We've then seen how to change into multicolor mode, which we do here. These 3 lines here. So we've got multicolor mode there, and we've seen here the extra colours we've got available to us and where we store them, and then what colours you use for your foreground to ensure that it becomes a multicolour character. Okay, and then this one here is obviously how to point your Vic chip at your custom characters area of memory. Okay, so I'll bring this video to an end now. In the next one we will look at enhanced high-res mode, which is high-res mode, so it's an 8x8 character, but we can change the background colour on different characters. However, we don't have as many, the number of characters available to us is a lot less. As I said in the first video, Manic Miner uses that, so we'll have a look at where they're using it and how to program it. And then once we've done all the character modes, which that will be the last one, we'll look at using maybe some tools like I think Character Pad is a tool you can use to actually design your characters and maps and things on the screen, and then export them so that you can use them in your code without having to manually do each character. Yeah, there's some good tools out there. Unfortunately, only for Windows really, but you can use Wine or something to get it working on Linux or Mac. So yeah, that's the sort of short-term roadmap coming up in the next couple of videos. So thanks for watching, and I'll see you on the next one.